In this lecture, we are going to learn about connecting our front end with the back end. We will start with an overview of the course, covering where we are, what we have learned, and what tools we have been using. Then we will look into Angular, first with a refresher about the theory of what we have implemented in the previous lecture, and then we will go into a bit more depth. After that, we will have the hands-on part where we will connect our front end and back end together. First part, the overview. Previously on Applied Programming, we can look at what we have learned as building blocks towards our goal to build a full-stack web application. In Lecture 1, we learned about Agile and architecture. We also looked into the skills and technologies needed. However, Agile and architecture are main building blocks that we use throughout the course. In Lecture 2, we learned about planning, requirements, user interface, design, and ethical considerations. In Lecture 3, we learned about relational databases and structured query language, SQL. This was also the first lecture where we started our implementation and we prepared a simple database that we will use in our full stack application, which we are building together with you throughout the course. In Lecture 4, we learned about application programming interfaces, APIs. We implemented a web API using ASP.NET Core, and we also connected it to our database. So, we basically created a simple backend for our application. In Lecture 5, we learned about Angular, and we also talked about user experience. In the hands-on part, we built our first and simplest front-end using Angular. However, our front-end is standalone and not connected to the backend yet. Now, let's reorder these building blocks that we have. At the bottom, we have the database, and we use SQL for both creating our database and also for manipulating the data. This is our data layer. Above the data layer, we have our web API. Then, we connected our data layer and the web API. Above these layers, we have our front end. Now let's look at other building blocks that we have. As you can see, all these other building blocks are the ones that we will actually use all the time. And in this lecture, we will learn how to connect our front end with our back end. In other words, we will Let's also remember the tools of the trade. We have looked into many different tools, such as PostgreSQL, that is our database. We use the client to access it, which is called pgadmin 4. ASP.NET Core is the technology for the RESTful web API. Angular is the technology that we use for the front end. But these are not all. We also used Visual Studio Code, which is our integrated development environment, IDE, and we used it both for back-end development and for front-end development. Swagger and Postman were the tools we used when we developed our API. Figma was the tool I encourage you to use for your layout designs, mockups, and blueprints. Jira was the tool I encourage you to use for teamwork and applying Scrum. Also, GitHub is a collaboration tool that I encourage you to use when collaborating on the code with your teammates. Part 2. Angular Basics. Angular in a nutshell. Angular is a web framework to build fast and reliable applications. Some Angular features are components, which split the code into well-encapsulated parts. Router, which provides a navigation toolkit. Command line interface, CLI, which speeds up the development using commands. Let's look at the tooling that we need. Node.js, so that we can use Node Package Manager (npm) to manage the dependencies and spin up a lightweight web server. In this course, we use Node.js 22.19.0 or 22.20.0. Notice that we choose the long-term support versions at the time of the course. We also need, of course, Angular. We use current Angular version 20 in this course, which was released on May 2025. If you have used earlier versions in the past, you will notice that the files generated by Angular CLI do not have the same suffixes for components, directives, services, pipes, and others. We also need a text editor. Angular recommends Visual Studio Code. If you use Visual Studio Code, it's also a good idea to install the extension called Angular Language Service, which was developed by the Angular team. We also need a terminal for running Angular CLI commands. The essential knowledge that we need is basic JavaScript knowledge, for example classes, and basic TypeScript knowledge. Essentials JavaScript classes. Classes are a template for creating objects. They encapsulate data with code to work on that data. A class can be defined in two ways: a class expression or a class declaration. In this example, we see class declaration. This is the most straightforward way. You declare a class directly using the class keyword, and here the class is named rectangle. In the second example, we see anonymous class expression. Here we are creating an anonymous or unnamed class and assigning it to a constant variable called myRectangle. The class itself has no name, only the variable does. The last example is named class expression. This combines both approaches. The class has its own internal name, which is rectangle in this case, and it is assigned to a variable, which is myRectangle. A class element can be characterized by three aspects. Kind is about what type of member is it. Field is a property, for example, display name in the code. Method is a function, for example, distance. Getter is like a property but runs code. Setter is like an assignment but also runs code. In this example, we don't have getter or setter, but you would know them when you see get and set keywords. Location is about where does it live. Static means it belongs to the class itself. For example, both display name and distance elements are static. Instance means it belongs to each individual object. In the example, X and Y are instance members. Visibility, public or private. We will give an example on that later in the next slide. Methods are defined on the prototype of each class instance and are shared by all instances. The static keyword defines a static method or field for a class. Static properties, fields and methods are defined on the class itself instead of each instance. Static methods are often used to create utility functions for an application, whereas static fields are useful for caches, fixed configuration, or any other data that doesn't need to be replicated across instances. Let's look at the code a little bit deeper. In this example, we define a JavaScript class named point and demonstrate the difference between instance members and static members. Constructor is a special method called when a new object or instance of the class is created. It initializes the instance's properties, setting this.x and this.y to the values passed in. These are instance properties. Display name is a static field or static property. It belongs to the class itself, not to any individual point object or instance. Distance is a static method. It belongs to the class itself. It takes 2 point objects, A and B, and calculates the Euclidean distance between them using the Pythagorean theorem, implemented via the built-in math.hypot function, which calculates the hypotenuse of a right triangle. Instance creation. 2 instances of the point class are created, P1 and P2. In the next block, we try to access static members on instances. Those lines demonstrate the core concept of static members, which are not inherited by instances. Attempting to access the static property display name or the static method distance on an instance P1 or P2 results in undefined. Note that this is not an error because accessing a non-existent property on an object is not an error in JavaScript. It just returns undefined, which is a primitive value that JavaScript automatically assigns to variables that have been declared but not given a value. Static members are defined on the class and are not copied to the objects created from the class. In the last part, we try to access static members on the class. Point.displayName. The static property is correctly accessed directly on the point class and logs point. Point.distance, P1, P2. The static method is correctly called directly on the point class using the 2 instances as arguments. It calculates the distance. Class fields are similar to object properties, not variables. Therefore, we don't use keywords such as const to declare them. In JavaScript, private elements use a special identifier syntax, so modifier keywords like public and private should not be used either. As seen in the example, the fields can be declared with or without a default value. Fields without default values default to undefined. By declaring fields upfront, class definitions become more self-documenting, and the fields are always present, which help with JavaScript engine optimizations. Using private fields, the definition can be refined as in the new example on the side. It's an error to reference private fields from outside of the class. They can only be read or written within the class body. By defining things that are not visible outside of the class, you ensure that your class's users can't depend on internals, which may change from version to version. Private fields can only be declared upfront in a field declaration. They cannot be created later through assigning to them the way that normal properties can. Private methods and accessors can also be defined using the same syntax as their public counterparts, but with the identifier starting with hash, as you can see in the example code. Inheritance. Extends keyword is used in class declarations or class expressions to create a class as a child of another class. In this example, we have an animal class, which is the parent class, And then we create a dog class, which is the child of animal class. We can also call dog as subclass and animal as superclass. Now this means dog inherits all properties and methods from animal. Dog can also add its own features or override inherited ones. Let's look at the parent class. Any animal can store a name and use the speak method. Let's look at the child class. Any dog also has a name, but dogs override the speak method with their own version. Dogs bark instead of making a generic noise. What does super do? Super calls the parent class's constructor. Let's also remind what this keyword does. This refers to the object that is currently executing the code. In the last two lines, we first create a dog named Mitzi. Then we call the speak method. JavaScript looks for speak method in dog class first, and it finds it. So JavaScript uses dog's version of speak method. Therefore, Mitzi barks. Now, as the prerequisite of this course is the object-oriented programming course where you learned C#, I would like to continue with TypeScript, but TypeScript for C# programmers. That would be the knowledge we will try to get. TypeScript's type system offers many of the same benefits as in C#, such as better code completion, earlier detection of errors, and clearer communication between parts of your program. We need to rethink the class. C# is what we might call a mandatory object-oriented programming language. In such languages, the class is the basic unit of code organization and also the basic container of all data and behavior at runtime. Forcing all functionality and data to be held in classes can be a good domain model for some problems, but not every domain needs to be represented this way. Free functions and data. In JavaScript, functions can live anywhere, and data can be passed around freely without being inside a predefined class or struct. This flexibility is extremely powerful. Free functions, those are not associated with a class, working over data without an implied object-oriented programming hierarchy, tend to be the preferred model for writing programs in JavaScript. Static classes. Additionally, certain constructs from C# as well as Java, such as singletons and static classes, are unnecessary in TypeScript. That said, you can still use classes if you like. Some problems are well suited to being solved by a traditional object-oriented programming hierarchy, and TypeScript support for JavaScript classes will make these models even more powerful. TypeScript supports many common patterns such as implementing interfaces, inheritance, and static methods. We also need to rethink types. TypeScript's understanding of a type is actually quite different from C#. Let's explore some differences. Nominal type systems. In C#, any given value or object has one exact type. The definition of this type will reside in a class somewhere with some name, and we can't use two classes with similar shapes in lieu of each other unless there is an explicit inheritance relationship or commonly implemented interface. These aspects describe a nominal type system. The types we wrote in the code are present at runtime, and the types are related via their declarations, not their structures. Types as sets. In C#, it's meaningful to think of a one-to-one correspondence between runtime types and their compile time declarations. In TypeScript, it's better to think of a type as a set of values that share something in common. Because types are just sets, a particular value can belong to many sets at the same time. Once you start thinking of types as sets, certain operations become very natural. For example, in C#, it's awkward to pass around a value that is either a string or an integer, because there isn't a single type that represents this sort of value. In TypeScript, this becomes very natural once you realize that every type is just a set. So how do you describe a value that either belongs in the string set or the number set? It simply belongs to the union of those sets. TypeScript provides a number of mechanisms to work with types in a set-theoretic way, and you'll find them more intuitive if you think of types as sets. TypeScript's type system is structural, not nominal. Let's look at an example code. Interfaces in TypeScript define the shape or structure that an object should have. They are like contracts that describe what properties an object must contain. The first interface block says a point-like object must have an X property and a Y property, and the second interface block says a named object must have a name property. Notice that X and Y are of type number and name is of type string. Then we have functions. LogPoint function accepts any object that matches the point-like interface, which means has X and Y as numbers. LogName function accepts any object that matches the named interface, which means it has a name as a string. Then comes obj, which wasn't explicitly declared as point-liked or named, but it can be used with both functions, because obj has X as number and Y as number, which matches point-like. Therefore, it can be used with LogPoint function. Obj also has name as string, which matches named interface. Therefore, it can be used in LogName function. This is TypeScript structural typing. In other words, TypeScript cares about structure, not explicit type declarations. In the example, we can use obj as a point-like because it has X and Y properties that are both numbers. The relationships between these types are determined by the properties they contain, not whether they were declared with some particular relationship. There's nothing at runtime that will tell us that obj is point-like. In fact, the point-like type is not present in any form at runtime. Going back to the idea of types as sets, we can think of obj as being a member of both the point-like set of values and the named set of values. Now we go back to Angular. Components. Every component has a few main parts. A component decorator that contains some configuration used by Angular. An HTML template that controls what renders into the document object model, also known as DOM. The DOM connects web pages to scripts or programming languages by representing the structure of a document, such as the HTML representing a web page in memory. A CSS selector that defines how the component is used in HTML. A TypeScript class with behaviors such as handling user input or making requests to a server. Using components. You build an application by composing multiple components together. For example, if you are building a user profile page, you might break the page up into several components like this. We have a user profile component. Under that we have user biography, under which there is user address. Also under user profile there is profile photo component. Here the user profile component uses several other components to produce the final page. To import and use a component, you need to add an import statement for the component you want to use. That needs to be done in your component's TypeScript file. You also need to add an entry to the imports array for the component you want to use. That happens inside your component decorator. You also need to add an element that matches the selector of the component you want to use. That goes inside your component's template. Here's an example of a user profile component importing a profile photo component. First we have a command line. Since we are not inside an IDE, the command is telling us that we are inside the user-profile.ts file, namely the user profile component. First line after the command line, we import another component called profile photo from a different file. You are bringing in a component so you can use it inside this one. Think of it like I need the profile photo component to use in my user profile component. The component decorator is special Angular syntax that marks this class as a component and provides configuration for it. Let's remember what's the decorator. It's a TypeScript feature written with @symbol in the beginning that adds metadata or functionality to a class. Think of it as attaching instructions to the class. Inside component we have the configuration properties. The first one we see is the selector. This defines the HTML tag name for this component. In this case, user-profile. Next configuration property is imports. This tells Angular this component needs to use the profile photo component, so make it available in my template. The next one is the template configuration property. This is the HTML structure that will be rendered when you use the user profile component. Notice that inside the template there is regular HTML tags like heading 1 and paragraph, but there is also custom component, which in this case is profile photo. So this uses the profile photo component we imported. Also notice that there is the backtick symbol which allow multi-line strings in JavaScript and/or TypeScript. At the bottom you see the component class. This is where we define the properties, methods, etc. However, it's empty for this example. We use Angular's template syntax to create dynamic user interfaces. Component templates aren't just static HTML. They can use data from your component class and set up handlers for user interaction. Showing dynamic text. In Angular, a binding creates a dynamic connection between a component's template and its data. This connection ensures that changes to the component's data automatically update the rendered template. You can create a binding to show some dynamic text in a template by using double curly braces. In this example, we not only see the use of double curly braces, but also start learning about the concept of signals in Angular. A signal is a reactive container for a value. It's Angular's way of tracking data that can change over time and automatically updating the UI when it does. The line with username assignment creates a signal that holds a value, which is ProProgrammer123, is reactive, meaning when the value changes, Angular knows to update the template, and it is a function, so you can call it like username parenthesis to get the value. When you look at the third line of the code, you will see that the signal called username is actually called like a method with empty parentheses. This actually is how we are reading the value of the signal username. When Angular renders this component, you will see the HTML code with the heading profile for ProProgrammer123. Angular automatically keeps the binding up to date when the value of the signal changes. Building on the example above, if we update the value of the username signal, then we will get this.username.set, and we can update it to a new value such as coolcoder789. The rendered page updates to reflect the new value, which will be again in HTML headings profile for coolcoder789. Setting dynamic properties and attributes. Angular supports binding dynamic values into DOM properties with square brackets. Let's look at this code. As you already know, this code structure defines an Angular component named userProfile. add_component is a decorator that marks the userProfile class as an Angular component. It provides essential metadata such as the template, CSS styles, and selector. Export class userProfile is the class where the component's logic and data reside. As you also already know, signal false inside the class is a signal, which is a reactive primitive introduced in Angular. It wraps a value, which is false in this case, and makes it observable for change detection. In this example, when the value of isValidUserID changes, for example from false to true, Angular knows exactly which parts of the template rely on this signal and updates them efficiently. Now let us look at what is new here. The line starting with template. This line defines the component's UI, which contains a button with a specific type of binding. Here we see disabled inside square brackets. This is property binding, or one-way data binding. It means the value inside the codes will be assigned to the HTML element's disabled property. We also see isValidUserID. Remember from the previous slide, this is how you read the value of a signal inside an Angular template. Since isValidUserID is a signal, it is a function. Calling it returns the current value, which is false in this case. You can also bind to HTML attributes by prefixing the attribute name with attr dot. Let's look at this code. First we have an HTML element, that is UL, which stands for unordered list element, typically used for lists of items. Then we have the attribute binding. We have attr.role inside square brackets. This syntax is called attribute binding. It is used when you want to set the value of an arbitrary HTML attribute. attr is the prefix and role is the attribute. Then we have the value source. List role is the expression whose result will be assigned to the role attribute. Since it's written with parentheses, it strongly suggests that list role is a signal or a method defined in the component's corresponding TypeScript class. Angular automatically updates DOM properties and attributes when the bound value changes. Handling user interaction. Angular lets you add event listeners to an element in your template with parentheses. This code is an Angular component code snippet that demonstrates event binding. Let's break it down. Template property contains the HTML that will be rendered. Here it is an inline template using backticks. Event binding syntax. That's where we see the click inside parentheses. The parentheses indicate event binding in Angular. Click is the DOM event being listened to. Cancel subscription is the method that gets called when the button is clicked. Then comes the component class. User profile contains the component's logic, including the cancel subscription method that handles the click event. Let's see how it works. When a user clicks the button labeled cancel subscription, Angular detects the click event. Angular automatically calls the cancel subscription method defined in the component class. Whatever code you write inside that method executes. If you need to pass the event object to your listener, you can use Angular's built-in $event variable inside the function call. This code is nearly identical to the previous example, but with one important addition, $event, which passes the native DOM event object to the method. The key difference, without $event, cancel subscription method receives nothing. With the $event, it receives the event object. So what is $event? It is a special Angular variable that represents the native browser event object. When you include it, Angular captures the actual DOM event, like mouse event for clicks. Angular passes it as an argument to your method, gives you access to event properties and methods. Some common uses of it is accessing the target element, for example, to get the clicked element, getting mouse position. For example, for click events, you can access the coordinates. Also, keyboard events. For example, you can access which key was pressed. Control flow with if and for. You can conditionally hide and show parts of a template with Angular's if block. In this example, the first line is regular HTML. We have heading 1, user profile, which always renders. Then comes an if block. This one conditionally renders the content based on whether isAdmin returns true. Let's see how it works. First, Angular evaluates the condition isAdmin. If it is true, the content inside the block is rendered, which is heading 2 admin settings. If isAdmin is false, the content is completely removed from the DOM. The if block also supports an optional else block. In this example, we have the control flow that conditionally renders one of 2 different blocks of content. Here again, first we have the regular HTML user profile heading, which always renders. Then we have if block, which renders when isAdmin returns true. We have else block, which renders when isAdmin returns false. Let's see how it works. So first, Angular evaluates isAdmin. If it's true, it shows admin settings and admin content. If it's false, it shows user settings, so regular user content. You can repeat part of a template multiple times with Angular's for block. We actually used for block in the previous lecture where we were iterating between student records in our very first Angular application. Let's break down this new example. Badge is the loop variable representing each item in the current iteration. Badges is the array collection to iterate over. It is actually calling a method that returns badges. Track badge ID tells Angular how to identify each item uniquely, that is, with their ID. Badge.name inside double curly braces is the interpolation that displays the name property of each badge. So here is how it works. Angular calls badges to get the array. For each item in the array, it creates an li, list item element. Uses badge.id to track which items are which, and then displays badge.name inside each list item. Angular uses the track keyword, shown in the example above, to associate data with the DOM elements created by for. In Angular, you use signals to create and manage state. A signal is a lightweight wrapper around a value. In the example, we use the signal function to create a signal for holding local state. Let's break down each part in the code. First, we create a signal. We do it with the initial value, Morgan. First name is now a special function that holds the value. Then, we read the signal. We call the signal like a function to read its value. This is important. Signals are actually getter functions, not plain variables. They return the current value. In the third part, we set a new value. So set replaces the current value with a completely new value, and Angular automatically notifies any components watching this signal. In the last part, we update based on the previous value. So the update takes a function that receives the current value and returns the new value based on the old one. Useful when the new value depends on the previous value. I also want to note that in this last line, inside the parenthesis, what you see is an arrow function, which is actually a short form of a function, in fact an anonymous function. This is very similar to lambda expressions in other languages, such as you might remember in C#. Why signals? First reason is the automatic reactivity. When a signal changes, Angular automatically updates any templates or computed values that use it. Second reason is fine-grained updates. Only components that read the signal re-render, not the entire component tree. Another reason is the simple API, just 3 methods: call to read, set to replace, update to transform. It is also type-safe with full TypeScript support. A computed is a signal that produces its value based on other signals. Let's look at this code. In the line with const first name assigned signal Morgan, a regular writable signal with the value Morgan is created. This is the source signal. In the next line, we have a computed signal. Computed takes a function that defines how to calculate the value. Inside this function, it reads first name, which creates a dependency. Then it returns the uppercase version. Next, we are reading the computed value inside console.log. We call it like a function to get the current computed value, which would be the Morgan in uppercase letters. A computer signal is read-only. It does not have a set or an update method. Instead, the value of the computed signal automatically changes when any of the signals it reads change. Let's look at this example. Here, the difference is the new line with firstName.set Jamie. Change the value of firstName from Morgan to Jamie. Angular knows firstName capitalized depends on firstName. Marks the computed signal as stale, which means it needs recalculation. Then we do the reading. We read the computed value again, and as Angular detects it is stale, it recalculates automatically. So firstName now returns Jamie. That to uppercase converts it to Jamie in capital letters. Now it returns the new computed value. Use signal and computed inside your components to create and manage state. Let's look at this example. Here we have two source signals. We have isTrial and isTrialExpired. Both are writable signals that can be changed with set. Then we have computed signal with logic, which is showTrialDuration. This creates a computed signal that depends on both source signals. Here is its logic. It returns true when user is on trial and trial has not expired. It returns false in all other cases. It automatically recalculates whenever isTrial or isTrialExpired changes. After that, we have the method to update state. That's the activateTrial method. It sets isTrial to true when called. This triggers showTrialDuration to automatically recalculate. Now let's look at dependency injection. When you need to share logic between components, Angular leverages the design pattern of dependency injection that allows you to create a service, which allows you to inject code into components while managing it from a single source of truth. What are services? Services are reusable pieces of code that can be injected. Similar to defining a component, services are comprised of the following: a TypeScript decorator that declares the class as an Angular service via @injectable and allows you to define what part of the application can access the service via the providedIn property, which is typically root, to allow a service to be accessed anywhere within the application. Also a TypeScript class that defines the desired code that will be accessible when the service is injected. Here's an example of a calculator service. First, we have the @injectable decorator, which marks this class as a service that can be injected into other parts of your app. ProvidedIn root means this service is a singleton, which means only one instance exists for the entire application. The service is automatically available everywhere without needing to add it to any module's providers array. Then we have the service class. This is a regular TypeScript class with methods. In this case, it has an add method that takes two numbers and returns their sum. It can contain any logic, state, or functionality you want to reuse. How to use a service. When you want to use a service in a component, you need to import the service, declare a class field where the service is injected, assign the class field to the result of the call of the built-in function inject, which creates the service. Here's what it might look like in the receipt component. In this example, the calculator is being used by calling the Angular function inject and passing in the service to it. In this example, we first import the dependencies we import the inject function from Angular core, and we import the calculator service that was defined elsewhere. Next is the component decorator, which defines a component with selector appReceipt. Template displays the total cost value using interpolation with double curly braces. Then we inject the service using the inject function to get an instance of the calculator service. It stores it in a private property called calculator. Angular's dependency injection system automatically provides the service instance, and here private means this property is only accessible within the class. Then we use the service. In the line with total cost assignment, we call the add method from the injected calculator service. It passes 50 and 25 as arguments. It stores the result, which is 75, in the total cost property. This executes when the component is created. Let's continue with the hands-on part. The first thing we need to do before connecting the front end with the back end is to make sure that both of these ends are actually up and running. So we will start by running the back end. We already created the back end in lecture 4, so you are welcome to use that. You can also just download the backend code from the course page or from the GitHub link I provided. If you are going to use the code that you downloaded, then the first thing you need to check is whether the connection string is correct for your own database. You can find the connection string inside appsettings.json file, and you need to make sure that the database name, username, and password are matching your own database that runs on your own computer. If something goes wrong, please refer to the Lecture 3 materials where we set up our database and Lecture 4 materials where we connected the database with the Web API. After that, we need to start an instance of Visual Studio Code. We click Open Folder and then open the backend folder. Inside this folder, we have course admin system.api. That is what we need to run inside Visual Studio Code. We can do that in different ways that I wrote down in the slides. In this demo, I will simply click the menu, Run, and start debugging. After this, you should be able to see Swagger running, as it was what was configured on the API project we did in Lecture 4. If you have a problem with Swagger, you can revisit Lecture 4 materials where we explain possible things that could go wrong, such as latest .NET version not supporting Swagger by default, in which case you can either lower your .NET version or simply install Swagger yourself. The second thing that we need to run is the front end. We created the front end in Lecture 5 and we will use that front end. Similar with the backend, you can also download the front end code from the course page or from the GitHub link I provided. Now, in order to run the front end, we will open a new window of Visual Studio Code and open the front end folder. After that, just like we did in the previous lecture, we will first run npm install and then run ng-serve. Eventually, we will see the link where we can click and see the simple web application we prepared before. Now we have both backend and frontend running, but they are not talking to each other yet. In order to connect these, we will first create a new service called Student Service. We will do that by executing the following command. Note that this command will not only create the TypeScript files for the service, but also create a folder named services. In the newly created student-service.ts file, we make the following changes. First, we add a new property, base URL, and set its value to the URL of our API. As you can see, the autocomplete in Visual Studio Code chose port number 3000. However, I go back and check the Swagger and write the correct port, which is 5050 in my case. Notice that the URL of the API is also not correct in the autocomplete, so I also corrected such that after the port we have slash and API. Now I need to add a constructor into this class with the HTTP client property. Notice that I need an import line, which is automatically added on the top of the file. After that, I need to add methods to this class. The first method I am adding is getStudents, as I described in the slides. This method is going to fetch all the students' data from our backend API. Doesn't take any parameters because it retrieves all the students, and it returns an observable that will be an array of student objects. Observable is like a stream of data that arrives over time. As the HTTP requests take time due to network delay, Angular uses observables to handle this asynchronous behavior. Now you will recall from the Web API lecture that actually we are now making an HTTP GET request to the base address of our API. So Angular's HTTP client will send the request to our server, and then it will receive the JSON response, and it will convert the JSON into an array of student objects. The second method I will add is very similar to the first method, so I am copy pasting the first method and then I am renaming it to getStudent, which will take a parameter that would be the ID of the student, which has the type number. So the difference in this method that instead of returning all the students, it's returning just one student, and it requires an ID parameter. And instead of returning a student array, it is actually returning a single student object. Also, the endpoint is different. Now, while using autocomplete and then copy pasting the previous method helped me to type faster, it actually also causes some issues. So at this point, for example, I thought that I typed correctly. However, I have a mistake here. So let's see how much time it will take until I realize that I forgot to add colons. Yes, one there and one there. I still have red highlighted text. I will correct them later. Now I'm adding the third method, which is the create student, which takes student as the input parameter. So what we are doing here is we take a student object as input, and then we are making an HTTP post request to the API. So we send the student data in the request body as JSON, and then the backend receives the data, saves it to database, and sends back a response. The last method I am adding is the delete student method, which takes a student ID as input, and then it makes an HTTP delete request to the API, and then the backend receives the request, deletes the student from the database, and sends back a response. After that, I can look at fixing the red highlighted bit. I can get help from Visual Studio Code, so when I click this suggestions, I realized that RxJS, I forgot to import that, so with one click I'm adding that as the third row on the top. Also the student has to be imported. I again click the suggestion and I add the student interface under model folder, as you can see on the fourth line of the file. I still have a problem, as I can see the red underlining below the return keyword, and I quickly see that I forgot to add the array symbols on the getStudent method, which was copied from the getStudents method. Now I need to go to appconfig TypeScript file, and here first I need to make a new import, which would be the provide HTTP client. That would be from the Angular common HTTP. Just a reminder, this file is the main configuration for our Angular application, and the addition that we are doing here with the provide HTTP client, we are enabling HTTP functionality in our app. This is very important for our student service because without it, it cannot use HTTP GET or POST. As you can see, at this point I start to get worried because there's red underlining below the provide HTTP client, but when we click that, we realize that it's just because it's not used yet. And that is actually the next step that we are going to follow. We just add the provide HTTP client call inside the provider's inside application config. And then of course I told you that it's Angular /common/HTTP. That was forgotten. So when we also add it, now we are good to go. In the previous lecture, one of the components we created was student list component. And in this lecture, we created the student service. Now, the next thing we will do is we will update the student list component to use the student service. To be able to do that, we will look at student list TypeScript file and add a constructor which takes the student service property. The first thing I do here is actually importing the student service, which is the service that makes the API calls. After that, I am adding the constructor, and this constructor is very interesting because, as we talked about in the lecture, with the constructor we are actually doing the dependency injection. So we are providing an instance of the student service. When we look at the imports, we see a line with the component decorator. Next to it, we are adding onInit, which is not a decorator, but is a lifecycle hook, a special method that Angular calls automatically at a specific point in component's life, which in this case when the component is born or created. So what we want to do here is when the component is created, the constructor will run first, but right after that we want this block with ng onInit to run immediately after. Before working on ng onInit, block, I am creating an empty array to hold the student data. And I am also going to delete the hard-coded student data. Now that we will connect our front end to our backend, we don't need to work with the hard-coded data. As I said, the ng on init will be running right after the student list component is created. So let's look inside it, what we are doing. First of all, we call the get students method from our service, and then we subscribe to get the data. So this part with the students is the part that will run when the API responds successfully. In such case, the students parameter contains the array of students from the API and then assigns the data to this.students so the template can display it. The next part is the error handling part. So if the API call fails, this part will run, and here it will log the error to help us with the debugging. It is important to give meaningful messages for the error handling. It will help a lot to debug our code when things go wrong. And talking about things going wrong, as I see the red underline, I realize that something is forgotten, and that's closing the parentheses and the semicolons. And now we are at a point that actually we can try the web application to see if it is really connected to our backend. So let's do that. Now we are testing our application. We will click on the student list link and we should be able to see some data, but we don't see the data. Now, as I wrote in the lecture slides, there can be a good reason behind that, and that is our backend perhaps is not allowing requests from the front end. In this case, we need to go to the backend project in the Visual Studio Code, and then we need to find the program.cs file, and we need to tell backend to allow actually calls requests from the front end. And now we are checking again. As you can see, it still doesn't work. Now we will do some debugging. Again, I wrote in the lecture notes that we can use the developer console, the JavaScript console. There we will actually see what kind of errors we are getting. We can see that the request is not allowed and then API error fetching students. However, we just fixed them. So perhaps what we need is a simple refresh. Let's see. Indeed, I quickly checked the files that I made changes. There aren't any errors, but I still want to have a quick look on the code, and I don't see actually any problems. So I go back and click again, and now remember to refresh the page, and voila, we can see the data. So actually it worked. As you can see, I have the 3 records we created in the previous lecture, the first 3, and then I also have another one which I added when I was testing the code, the student with, you will see with the ID number 6. You can also do tests yourself using Swagger, as we showed in an earlier lecture. You just need to go and enable by clicking try it out and fill in. And now we reach the final part of this lecture where we will add delete functionality. And so in order to do that, let's look at the student card component. So this file is actually what we call a template, an Angular HTML template. And here we are displaying a single student's information in an HTML table format. We also use this interpolation technique, which you remember, with the double curly braces, such that we display data from our TypeScript component inside in the HTML. Now, at the bottom of this table, we are creating a new row with the tr tag, and in this row we are actually adding a button. That's the delete button, and when clicked, Angular will detect the click event, and then Angular will call delete student method in our component, and that method is executing the delete student method, which actually also takes an ID. Next thing I need to do is, in the same component, I need to go to the TypeScript file, and first I will make a new import that is the student service that we created in this lecture, and then I need to create a constructor for the student card class where I am again doing the dependency injection with the student service. And then inside the class, now I am defining the delete student method that will run when we click the delete button. What this method does is actually very simple. It's calling the service to delete the student by the ID of the student. The subscribe method triggers the HTTP request, and then this method is actually not returning anything. That's why it says void next to the method. I can see that I made a mistake with the curly braces, so after I fix them, we are also good to go. And then the next thing we will do is to try the delete button. Now we are testing again, and I am trying to delete the records with ID 6 and ID 7 so that we again just have the 3 records that we originally had. I click the button, but I still see the records, so now I want to test it from the Swagger as well. What I want to do is actually I make a request to see if there's a record with the ID 6, and I actually get the success code, which shows that there is actually the record with the ID 6 still there in the database, and the same goes for number 7, which actually tells me that the delete button did not work. So now we need to go debug our code just like we did before. As I didn't change a lot of files, what I'm going to do is again I will look at the files that I made the changes. I made a change in the HTML template. I actually have a little mistake here. I forgot to use the TD tag, but it shouldn't be a showstopper. And then I look at the delete student method. I have a mistake here as well, and now I can see that the subscribe is actually method, so it actually requires parentheses. So let's see how long it will take until I realize my mistake. I found it. So now I make the change and I save it, and then I go back to the page, and now I click the delete button for the record 6.
and now it's gone on the web page. And the same for 7. I want to double check using Swagger, so when I execute this time I get the error not found code, which means that our code works as expected.